If you walked down the street today and asked a random person if they felt the universe was close to them, they would probably say it feels incredibly far away. In most people's minds, space exploration is still something reserved for scientists in white coats or a staggering line item on a national budget. It is seen as a matter of dreams and exploration, but almost never as a matter of making money. However, I am here to tell you that human civilization is at a massive wealth tipping point. Just as the European merchant fleets of the 15th century first connected the Americas via Atlantic routes, or the 19th century railway networks completely reshaped continental trade, we are standing on the starting line of the great space age. The difference this time is that the driving force is no longer the Cold War hegemony of superpowers, but cold, hard, and incredibly tempting commercial logic. Why is this happening now? The answer lies in one phrase: the cost of getting into orbit. In aerospace engineering, there is a fundamental metric we can call the price of a ticket to space per kilogram. During the Apollo era, or the era of the space shuttle, sending 1 kilogram of cargo into low Earth orbit cost about $20,000 to $30,000. This meant that if you wanted to drink a bottle of mineral water on a space station, the shipping cost alone would be equivalent to a down payment on a luxury car. This exorbitant price made space a luxury reserved for the few. But with commercial aerospace companies achieving total rocket reusability, this price is undergoing a catastrophic collapse. Current costs have dropped to a few $1,000s per kilogram, and with giants like the Starship capable of carrying over 100 tons and taking off as frequently as a commercial airliner, that number is expected to drop below $100 per kilogram within the next decade. Remember this key logic: the scale of space commercialization is inversely proportional to the square of the launch cost. When the cost is reduced by 10 times, the possibility of commercial applications increases 100-fold. When the price is low enough for an average company to afford, space is no longer a laboratory you can only look at but not touch. It becomes a massive, untapped virgin territory. Today, we are going to dive deep into where the money is hidden in this trillion-dollar interstellar map. The most mature and profitable sector in the space economy right now is the low Earth orbit communication constellation. You might already be familiar with the name Starlink, but most people only see it as a way for people in remote areas to access the internet. They fail to see the logic of digital land rent behind it. First, there is the absolute advantage of breaking physical latency. We need to understand an interesting physical phenomenon. The speed of light in fiber optics is actually about 1/3 slower than the speed of light in a vacuum. This means if you use underground fiber optics to transmit data between London and New York, the signal will move slower because of the refraction in the glass medium. But in the vacuum of space, signals fly at the pure speed of light through laser links between satellites. For an average person, these few dozen milliseconds of latency make no difference. But for a high-frequency trader, being 20 milliseconds ahead of a competitor means being able to predict market trends and complete tens of thousands of arbitrage trades in a single second. This latency advantage makes satellite networks a necessity for Wall Street and global financial centers. They are willing to pay a monthly fee hundreds of times higher than an average household just to buy those few milliseconds of lead time. This is the ultimate manifestation of the phrase time is money on a physical level. Then there is the complete disappearance of marginal costs. On Earth, if you want to provide network coverage for a remote island with only a few hundred people, you need to lay thousands of miles of deep-sea cables, and the cost is astronomical. But from a space perspective, satellites are global roamers. They earn money when they fly over New York, and it is a waste if they are not utilized when flying over the Pacific Ocean. Therefore, the commercial formula for satellite internet is very attractive. The construction cost is a fixed investment, but the service area is global. This means that for every additional user, the added cost is almost negligible. When the user scale breaks a critical point, say 30 to 50 million users, the system becomes a printing press for money. By 2030, we will no longer be talking about mobile phones surfing the internet, but the direct connection of all things. Autonomous vehicles, unmanned cargo ships in the ocean, sensors in forests, and even a smartwatch in the middle of nowhere will no longer need to look for a ground station signal but will talk directly to satellites hundreds of miles above. Whoever controls this satellite web owns the distribution rights and the voice of global data. This is not just commercial competition, it is the foundation of future digital civilization that if you think space is only for transmitting data, you are vastly underestimating it. Another huge gift space brings to commerce is microgravity. On Earth, all our manufacturing processes are subject to gravity. Gravity causes convection in liquids, makes heavy substances sink, and light substances float. This sounds natural, but in high-tech manufacturing, it is a nightmare. Consider the synthesis of perfect materials, such as the wafers used in high-performance semiconductor chips. When manufactured on Earth, internal impurities and irregularities occur due to the influence of thermal convection. But in the microgravity environment of orbit, where convection is gone, we can grow crystals with nearly perfect structures. There is an even more promising product, ZBLAN fluoride fiber optics. The theoretical signal loss of this fiber is 100 times lower than the quartz fiber we use now. But when pulling this fiber on Earth, gravity causes tiny crystals that make the fiber fragile and the signal blurry. If manufactured in the microgravity of a space station, it becomes incredibly clear. Here we introduce a concept, the value-to-weight ratio. Although shipping things up is expensive, if a certain product cannot be made on Earth at all, and its value per gram exceeds thousands or even tens of thousands of dollars, like specialty drugs or high-end superconducting materials, then the expensive launch fee becomes a minor logistical cost in the face of massive profits. Three-dimensional bioprinting and human organs are currently the most exciting blue ocean. On Earth, it is difficult to print a complete heart or liver because, under the influence of gravity, soft biological cell tissues collapse like a pile of mud. To support them, we have to use complex scaffold materials. But in space, these cells can be suspended in mid-air, growing perfectly according to a predetermined structure. This means that future orbital factories might be repair stations for human organs. This scarcity that cannot be replicated on the ground will make space medicine one of the most profitable sectors in the world. As we move beyond Earth's orbit, the next major frontier in the trillion-dollar space economy is our closest neighbor, the Moon. For decades, the Moon was a destination for flags and footprints, a symbol of national pride. But in this new era, the Moon is being redefined as the eighth continent. It is no longer just a barren rock, it is the strategic high ground and the essential logistics hub for the entire solar system. To understand why billionaires and governments are racing back to the lunar surface, you have to understand the most valuable substance in space. It isn't gold, and it isn't platinum. It's water. We've discovered that the lunar South Pole, specifically in craters that never see sunlight, holds billions of tons of water ice. In the context of the space economy, water is the interstellar currency. Why? Because water is the raw material for life and, more importantly, for propulsion. By using electricity from solar panels to split water into hydrogen and oxygen, you create high-performance rocket fuel. The economic logic here is a game changer. Right now, every drop of fuel a rocket uses to go to Mars or to move a satellite must be lifted out of Earth's massive gravity well. This is incredibly inefficient. It's like trying to go on a cross-country road trip while carrying every gallon of gas you'll ever need in the trunk of your car. If we can harvest water on the Moon and turn it into fuel, the Moon becomes the gas station of the solar system. The cost of launching a payload from the Moon is roughly 5% of the cost of launching it from Earth, simply because the Moon has 1/6 of our gravity and no atmosphere to create drag. This creates a massive arbitrage opportunity. Companies that control lunar water will control the supply chains of deep space. They will provide the fuel for satellite servicing, for deep space habitats, and for the first human missions to the asteroid belt. This is the birth of the cislunar economy, a marketplace that exists entirely between the Earth and the Moon. Beyond water, the Moon offers another long-term economic jackpot, helium-3. This is an isotope that is rare on Earth but abundant in the lunar soil, deposited there by billions of years of solar wind. Helium-3 is considered the ultimate fuel for future nuclear fusion reactors. Unlike current nuclear power, helium-3 fusion is projected to be clean, producing no radioactive waste. A single cargo bay full of helium-3 could potentially power a major city for a year. While we are still mastering fusion technology on Earth, the companies securing mining claims on the Moon today are positioning themselves to be the energy titans of the next century. But how do we move all this material? This leads us to the concept of space logistics and mass drivers. Imagine a miles-long electromagnetic rail built on the lunar surface. Because there is no air, you can accelerate a cargo pod to escape velocity using only electricity. You can literally shoot lunar minerals or fuel pods into orbit without using a single drop of traditional rocket propellant. This infrastructure will turn the Moon into a massive industrial export hub. The business model for the Moon also includes lava tube real estate. These massive underground caverns, formed by ancient volcanic activity, provide natural protection from solar radiation and micrometeorites. Instead of building expensive shielded structures on the surface, we can move our factories, data centers, and habitats underground. Developing these tubes will create a whole new sector of space architecture and extraterrestrial construction. We are also seeing the rise of the lunar land grab. Although international treaties say no nation can own the Moon, the reality of safety zones means that whoever lands a mining rig first effectively controls that territory. The first companies to establish a permanent presence at the peaks of eternal light, spots on the Moon that receive nearly constant sunlight for power, will have an insurmountable competitive advantage. They will own the power grid, the water supply, and the transportation hubs of the lunar world. This isn't just theory. NASA's Artemis program and China's Lunar Research Station are already laying the groundwork for this infrastructure. But the real money is coming from the private sector. Startups are already building lunar landers, autonomous mining bots, and orbital tugs. They are not looking for scientific samples, they are looking for a return on investment. The Moon is the first step in proving that humans can not only survive in space but thrive economically. It is the training ground for the ultimate prize, the asteroid belt. That if the Moon is the gas station of the solar system, then the asteroid belt is the ultimate treasure vault. This is the stage where we move from talking about billions of dollars to talking about quadrillions. Within our solar system, there are millions of asteroids, the leftovers from the birth of our planetary system. Many are just piles of rubble, but a significant number are concentrated blocks of pure wealth. Take for example the asteroid known as 16 Psyche. Located between Mars and Jupiter, this massive object is over 100 miles wide and is made almost entirely of iron, nickel, and gold. Current estimates place its value at $10,000 quadrillion. That is a number so large it exceeds the entire global economy of Earth by thousands of times. But the real commercial interest isn't just in gold. It's in the platinum group metals like palladium, iridium, and platinum itself. These are essential for everything from high-end electronics to the hydrogen fuel cells that will power our green transition on Earth. On our planet, these metals are incredibly rare and difficult to mine. In space, a single metallic asteroid just a few hundred feet wide could contain more platinum than has ever been mined in all of human history. The business model for asteroid mining is evolving. We are no longer just dreaming of landing humans on these rocks with pickaxes. The future is autonomous and robotic. Companies are developing prospecting drones that can calculate the exact mineral composition of an asteroid before we even commit to a mission. The technical challenge is the return on investment. You have to move the asteroid, or at least the processed ore, back to a place where it can be used. This leads to the value-to-weight logic. In plain text, the economics look like this. The profit of an asteroid mission is equal to the market value of the refined minerals minus the massive cost of the fuel and time required to reach the asteroid, capture it, and process it in zero gravity. In the beginning, we won't bring the minerals back to Earth because that would crash the global markets. Instead, we will use these minerals to build space-based infrastructure. Why launch a massive steel beam from Earth's heavy gravity when you can 3D print it in orbit using iron mine from a passing asteroid? This is the shift from a launch and use economy to an in-space manufacturing economy. As the money starts to flow, the question of who owns the stars becomes the most important legal battle of our century. According to the Outer Space Treaty of 1967, no nation can claim sovereignty over a celestial body. It was designed to prevent a nuclear standoff in space, but it didn't account for a private company wanting to mine a rock. Today, we are seeing the rise of the first mover advantage. New frameworks like the Artemis Accords are introducing the concept of safety zones. The logic is simple: if you are operating a multi-billion-dollar mining rig on an asteroid, you have the right to a zone around your operation where no one else can interfere. While not technically ownership, it is exclusive use, and in the world of business, those are essentially the same thing. The nations and corporations that define these rules now will be the ones who collect the space rent for the next 1,000 years. We are witnessing a 21st century enclosure movement, where the commons of the universe are being carved into private assets. This brings us to the interstellar wealth paradox. If we successfully harvest $1 quadrillion worth of gold, does gold lose its value? On Earth, yes. But the true wealth of the space age isn't in the currency, it's in the post-scarcity economy. When resources are no longer limited by what we can dig out of a single planet's crust, the cost of living, the cost of energy, and the cost of building a civilization drop towards zero. We are moving toward a future where we stop fighting over the limited scraps of one world and start harvesting the infinite bounty of many. The first trillionaire will not be someone who made an app, it will be the person who successfully secured the logistics of the asteroid belt. They will be the ones who provided the steel for our space stations, the fuel for our starships, and the rare metals for our technologies. The universe is no longer a silent, cold background to our lives. It is the greatest economic engine ever discovered. We are the generation that gets to see the great opening. The transition from being a one-planet species to a multiplanetary civilization is, at its heart, a transition of our economy from finite to infinite. The stars are not just points of light, they are the beacons of a new era of prosperity. As the cost of the space ticket continues to fall, the barrier between you and the wealth of the cosmos is disappearing. The question is no longer if we will colonize the solar system, but who will own the infrastructure when we get there. The frontier is open, the stakes are higher than they have ever been, and the voyage has just begun. I'm your host, and this is the future of our civilization. Stay curious, because the next gold rush isn't happening on Earth, it's happening right above your head.